Hey all, today we're going to verify if a point is on a line, and we're going to verify that graphically and algebraically. So previously we've been graphing lines that are in slope-intercept form, so we know how to do that, and we want to double check, just refresh our memory on that, and then double check if points lie on a line, and we can do that algebraically as well. So let's go ahead and see the question that we have here. Determine whether point 2, -2 lies on the line with the equation y equals x minus 4. It gives you room to do it algebraically on this side, and then it wants you to graph it and check to see if that point is on the line as well. I'm going to go ahead and refresh your memory first on the graphing part. So if I'm given an equation, remember that equation is in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. What are the two most important things in slope-intercept form? Remember, your slope is m, and your b value is your y-intercept. Those are the two most important things that you need to remember. Okay? So let's go ahead and look and see what I got here. So what is my slope of this equation? What is my number in front of x? I don't see one there, but what's always known to be there? Very good. 1 is known to be there. So my slope is 1. Remember, slope is rise over run. So how do I make that a fraction? Because I only have a rise right now. To remember, to make anything a fraction, put it over 1. Now let's identify my y-intercept. My y-intercept is my b value at the end. So my y-intercept in this situation would be -4. In order to graph it, I start at my y-intercept. So I'm going to start where y equals -4. So go put a dot on your y-axis where it equals -4. Then I'm going to do my slope. The 1 in the rise tells me to go up 1. The 1 in the run tells me to go right 1. Do that as many times as you can. Up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Then go back to where you started at your y-intercept and do the opposite. The opposite of up 1 is down 1. The opposite of right 1 is left 1. Get as many points as you possibly can. Then go ahead and try to use a ruler or a straight edge, some side of a paper or something. Make your line and extend it. Put arrows at the end to show that it goes on and on forever. Now my question is 2, -2 on the line? Well, let's go find the point 2, -2. Remember, x then y is your ordered pair. So I go to x equals 2 and to y equals -2. And I am right on the line. So yes, it has worked out graphically. Well, it most certainly should work out algebraically then, but I'm going to go ahead and show you just so we can double check. So if I'm given my equation, and I want to check to see algebraically if this point lies on the line. Remember, this is x and that's y. So substitute then into your equation. Y is -2, x is 2, and then leave the rest of the equation. So my goal is to see if this side is going to equal what the left side equals. 2 minus 4 is -2. They both end up equaling each other. It works out. So that shows me algebraically that this point does indeed lie on the line. So I have proved it both algebraically and graphically. All right, let's look at my line, or my line that I got going on here. Determine whether this point, 4, -3, lies on that line. So let's go ahead and check it algebraically. Remember, for a point, your first is x and your second is y. So let's plug them in where we see them. So I substituted for y, I substituted for x. Now my goal is to see, I already know what the left side equals. Does this right side equal -3? -2 times 4 is -8. -8 plus 5 is -3. So it ends up working. Yes, this point lies on the line. I've solved it algebraically. Let's check graphically. All right, I got my equation. Is that in slope-intercept form? Remember, it's got to be in y equals mx plus b in order for me to be able to graph it. And it actually is. So identify the most important things, your m and your b. What is my slope? My slope is -2. Remember, in order to graph, I need it to be a fraction to have a rise over run. So make it a fraction by putting it over 1. My y-intercept is 5. Remember, I start at my y-intercept. Where does y equal 5? Put a dot. Then I'm going to do my slope. The -2 in the rise tells me to go down 2. The +1 in the run tells me to go right 1. Keep going there. Down 2, right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. Can't go any further. Go back to your y-intercept where you started. Can I go up 2, left 1? I can't. So, connect with a ruler as best you can. Put arrows on the end to show that that line keeps going and going. Let's check. Now that I've graphed it, check. Do I see this point on that line? Remember, that's x and then y. So x is 4, y is 3. Yep, I am on the line. So I have proved it algebraically and graphically. All right, we're going to go ahead and skip 3. You're going to do that later on. So you can either pause it and do it now, or you can do it once the video is done. We're going to jump to number 4 first. So let's look at number 4. Determine whether point 2, -2 lies on the line with the equation y equals -3x plus 1. So let's check it algebraically. Remember, this is x. The first point is x. The second point is y. Plug them in where they belong. So y is -2. So -2 equals -3 times x, which is 2, plus 1. I already know this side equals -2. Hopefully, I can get this to equal -2. So -3 times 2 plus 1. Do your multiplication first. -3 times 2 is -6. -6 plus 1 is -5. Do those two things equal each other? Does -2 equal -5? No. Put a slash through it. So does this point lie on that line? No. Let's make sure we can understand graphically why that doesn't work. So is this in slope-intercept form? It is. It's in y equals mx plus b form. Let's identify the most important things in order to graph. My slope is -3. Make it a fraction by putting it over 1. My y-intercept is 1. Start at your y-intercept. Then do your slope. -3 in the rise tells me go down 1, 2, 3, and +1 in the run tells me to go right 1. So down 3, right 1. Go back to where you started, that y-intercept. Opposite of down 3 is up 3. Opposite of right 1 is left 1. And I can actually put one more dot. So I can get 4 total dots. Try to use a ruler. Be a little bit straighter than me. All right, let's check this point, 2, -2. The point 2, -2, over 2 on my x, down 2 on my y, that's right here. Is it on the line? It is not. So this point is not on the line. All right, I did number 1 with you, number 2, and number 4. You guys are going to do 3, 5, 6, 7, and 8. So basically, you're doing the rest of them. Then you're going to take a picture and upload it to the Google Classroom assignment. If you have any questions, email me or send me a remind message. Make sure you check your Google Slides if you have any further questions as well.